This is day 47 of coding every day until I hit 1K subs. This is day 47 of coding every day. Kicked things off today by diving into a Google text-to-speech tool I'm working on. The main focus was testing out some SSML, which stands for Speech Synthesis Markup Language. It's pretty cool because it lets you control how the synthesized speech sounds, like adding pauses, changing emphasis, or even specifying pronunciation for certain words. I was just experimenting with some different SSML tags to see how they affect the output. Alright, after that, I jumped into some LeetCode. First up was problem 2942, find words containing character. Spoiler alert, the task is pretty straightforward. Given a list of words and a character, we need to return the indices of all the words that contain that specific character. So here's the solution I came up with for finding words containing a character. It's a simple iteration. We just loop through each word in the input list, keeping track of its index using. For each word, we perform a check to see if the target character is present within it. If the character is found, we append the current word's index to our results list. This approach is quite direct. The time complexity is roughly order n times m, where n is the number of words and m is the average or maximum length of a word, due to the operator potentially scanning each word. The space complexity for storing the result is order k, where k is the number of words that actually contain the character. Next up, I decided to tackle a hard one. Problem 3068. Find the maximum sum of node values. Another spoiler warning. In this problem, we're given a tree structure, an array of initial values for each node, and a positive integer. We can perform a specific operation any number of times. Choose any edge connecting two nodes, say, and boven, and then update their values by XORing, both numsWidth and numsWidth. The ultimate goal is to maximize the sum of all node values in the tree after performing these operations. Here's the Python solution for maximizing the sum of node values. The key insight is that applying the XOR operation on an edge effectively means we can choose any pair of nodes in the tree to have their values XORed with. To maximize the sum, we want to make an even number of such XOR modifications. The algorithm first calculates a potential _max_sum by iterating through each node and greedily choosing to use its XORed value XORk, if that's greater than its original value. It also counts how many nodes, XOR_preferred_count, preferred this XORed state. If this count is even, the potential _max_sum is our answer. If the count is odd, we must make one adjustment to ensure an even number of nodes are effectively XORed. This adjustment involves subtracting the min_penalty_ to _flip_parity, which is the smallest absolute difference between any node's original value and its XORed value. This makes the number of chosen XOR states even with minimal impact on the sum. This greedy approach works in order n time, where n is the number of nodes, and uses order 1 or constant space. And that's a wrap for day 47. If you enjoyed this or found it helpful, please hit that like button, subscribe for more daily coding, and let me know in the comments what you're working on, or if you have any questions. You can also support the channel over at buymeaboba.com, link in the description. Every little bit helps keep these videos coming. See you tomorrow.